So in this video, what we're going to be talking about is haloalkanes. And a haloalkane is just a carbon chain, and if we're talking about a haloalkane, we're talking about a singly bonded carbon chain with a halogen coming off of one part of it. If we're talking about a haloalkene, we'd be talking about a doubly bonded carbon chain with a halogen coming off. And so in this example down here you can see that we have a singly bonded carbon chain with a halogen coming off of it. And so there are several ways that we can go about making haloalkanes. And so the first way we can go about making it is by applying Br2 in the presence of Hnu. Hnu is represented by this symbol down here. Hnu is pretty much just light. It's a fancy way to say light or heat. And so if we apply Br2 in the presence of Hnu, we can see that a bromine actually forms in the most tertiated position on the alkane. And so in our starting off alkane, you could see that this carbon right over here is the most tertiated carbon, and so the bromine would form there. And if we had a different example with a more tertiated carbon, the bromine would form in that position. The next example that we have is an alkene in the presence of NBS. And so this is a pretty useful reaction in organic chemistry, and you'll see it even more in organic chemistry too. And what this does is it'll actually keep the double bond present in your alkene, so it won't convert it to an alkane, and it'll apply a halogen to the neighboring carbon of your double bond. And so not to the carbon of the double bond exactly, but to the neighboring carbon. And so in this example, we're talking about this carbon, and you can see that the bromine formed. And so that's a useful way to form a haloalkene. The next reaction which we'll talk about is HBr in the presence of an alkene, and we've actually already seen this reaction in the alkene video. And what happens here is the bromine adds in the tertiated position of the double bond, while the hydrogen adds in the less tertiated position of the double bond. And so in this particular example, the hydrogen is adding here, and the bromine is adding in the more tertiated position down here. Now, what if we wanted to add the bromine to the Markovnikov position, or the less tertiated position? And so another way to ask that is, well, what if we wanted to switch where the hydrogen and the bromine get placed? And so what we do in that scenario is we would apply actually HBr in the presence of peroxide, which is represented down here through ROOR, R being some group, and the two O's being the peroxide. And so if you apply HBr in the presence of peroxide, you can see that the bromine actually forms in the less tertiated position, in the Markovnikov position, which is represented by this carbon over here, while the hydrogen forms in the more tertiated position, so the non-Markovnikov position is shown by here. And so these are the different ways that we can go about forming haloalkanes or haloalkenes.